Today we are going to cover Chapter 9, String. String is one of the important data structure in C language, and basically it deals with all of the text, message, and data format. And usually it is quite important for file processing as well. And then usually it is used to process the data from the input. So text is the simplest format of data files. So what is string? In C language, actually, there is no string. But let's discuss the general definition for string. So general definition for string actually is a sequence of characters are treated as a group. So it's a group of text. So usually we deal with the file name or output string. And sometimes actually also deal with the input format. Because we read data from file or keyboard, deal with the input, some information. So strings are important in many programming contexts. So in the old day, like 1970 to 1990, before the Windows come out, basically all programming are dealing with strings. So string is actually the center part for programming. Until the multimedia come out, we start to have image, we start to have audio, we start to have video. Before that, all processing are basically on text. So even today, text processing and also compilation still be very important. So string still be very important because right now a lot of information or resource are actually described in JSON file or JSON file. Okay, this type of different JSON object files. So basically, string is very important. But in C language, what we will discuss today is the representation of the string in C, string literals, string variable, string input output, and then string functions, and finally the formatting and reading from the string. Okay. So now first the C language representation. In C language, there is actually no string type. C language only has this thing called character array type. So basically, C language only has array type, but character is one of them. And usually, character has sign if you use the data. So sometimes using unsigned character would be better. Because when you add or the subtraction, especially dealing with 255, anything above 127, you don't want to let it become a negative number. So unsigned character is more appropriate. So you can do unsigned character name and 4 element of the array. That is a better representation actually. And that's one thing. String in C language actually is a array of characters. And second thing is like the ending symbol string, C language doesn't handle it. So basically you have to insert or put appropriate \O in there to mark the end of the string. It doesn't mean that the other language don't have this. They just hide it from the users. So string in C language, no explicit type. Instead, string are maintained as array of characters. So representing string in C language stored in array of characters. Array can be of any length. End of string has a delimiter, and that's character 0. These are easy. So character and string, C language only has concept of number and characters. It very often comes as a surprise to some programmer who learned beginner's language, such as BASIC, that C has no understanding of string, but a string is only an array of characters, and the C does not have concept of arrays, which we shall meet later in this course. And actually, C's main concept of array is very weak. It's actually more represented by pointers. So actually, in C language, even string processing will rely on pointers a lot. So C actually use the pointer more than any other language. And pointer in C actually is more like indirect addressing. So you actually use a pointer to find out the address and then access some other data. A pointer is of that purpose. And then array is only a address calculation scheme for pointers. So notice that you can only store a single character in a character variable. Later, we will be discussing using character strings, which have a very real potential for confusion, because a string constant is written between double quotes. But for the moment, remember that a character is single quote A, not double quote A. Double quote A is a string. Single quote A is a character. So to represent a string, you can be an array of characters like this. But these two are actually not a string because they don't have the termination symbol or delimiter. So these two can only be viewed as array of characters. And then these statements declared and initialized array of characters. They represent a collection of characters. Okay, so string operation don't apply to them. And the real array of character for string is still not like that. Here we have two more versions. One is using CLK, size of 1, so that's only one memory location for a character that assign the data to B. And this is legal. And this one is not legal because right-hand side is a character array type. So actually right-hand side has a solid array, but left-hand side only have the address. Okay, so this is not the right assignment. So you need to use this type to accept the data and then assign to some pointer. So these two both hold the address value. Basically, the first one and second one, these two both hold the address value for the array of characters. They can be used interchangeably in many places, but only the initialization part you cannot change. Is that okay, Eric? Hello? Hello, is that okay?
Yes.
So only this situation, you cannot change them, okay? So here we have the character array 0. So in this program, we have this undefined character, undefined array of characters, and then array character of fixed size. And the third one, this one, if you assign this, it won't work. Okay, so we omit it. Fourth one, you put into this type of array of character, that's fine. Fifth one is only a pointer. So fifth one, we can allocate a dynamic memory and then put something in there. So this different type representing different way of putting the data. Number one, we only have a pointer address, but that one actually is an array. So we are pointing to a undefined array, something like that's number one. This one is actually a pointer, but it actually is an undefined length. Second one is a fixed size. Since A2 store the address for the starting address for the array, but it has a fixed size. The size has been determined. Number 3 is a pointer, same as number 5, and this since A3 or A5 actually only a address, and it is used to point to different things. A4 again is a pointer, but it has already given a array of character, but this one actually is using array of character format, but it's pointing to there. Okay, number 5, later it got assigned by certain memory, and it's actually in heap. Okay, so the rest of them actually are in global area. Only this one, number 5, is in heap. It's dynamic. It's come to life only when you actually allocate the memory for it. Okay, after that we actually just print the different array in a string format, and the print now is on the right. So I think this program, we don't want to run it. This is good enough. So basically there are 4 different ways of declaring a array of characters. So here, string literal. What is string literal? String literal is the string representation in C language. So here, actually, the first one, empty string using double quote, no space in there. And this one is a single string, and this one is a string. This one is a character. So this is fine. And remember that character is using a single byte ASCII code in C language. So referring to the string literals, so here actually we get the hello's first character. So hello's first character, index 1, you will get E. So during comparison, C creates space for each string literal. So actually those string literal actually will be put in some area. Okay, so this one actually is legal. This one actually is legal. Okay, in C language is legal. Actually, this one is a string, and this one is only an address calculating scheme. So basically, you reserve some area for hello, right? And then this data type, as we say, is actually character undefined array size pointer. This is not using this. Okay, it's actually this type, but actually this one's not type, and then it's starting address right here. So actually we have temporary pointer that don't show the value, but it actually increased by 1. We'll go to here to get this one. This one, so it actually some temporary address value plus 1 and get its body. You want to get this. Is that okay so far, Eric?
Yes.
Okay, so that's how this temporary string will work. Okay, so that one is easy. Let's go. Duplicate the string literals. If you duplicate each string literal in C language stored in different location. So this is different from Java. Okay, this is different from Java. So this hello assigned to this. This hello assigned to this. So when we use equal to check, it's not equal. Because when we check with equal sign, it's checking the pointer starting address value, they are not equal. But in Java, they are the same. In Java, this kind of literal, like H, it will be stored in the same location. Okay, and then you do string S1 and string S2 equals H, right? Then the two literal pointing to the same H. If this is using this, this we call the interned string in Java.
So S1 and S2 are not equal?
S1 and S2 in Java are equal. When you
but
do
in C
S1,
is not equal.
S2. This one, string 1 and string 2 are not equal in C language. In Java, they are equal. In Java, they put this double quote H are actually indicating the same.
But if you use string compare in C, it would be the same.
Yeah, string compare is character by character. So this side actually, if you do string in Java, you have a string S3 equals string. Here new string, and then H. In that case, difference because this one actually stored in heap. But these two interns string stored in global area in Java. Okay. So in Java, if you use a string S3 equal new string H, that actually is the different object. So you have to know about this different detail when you do comparison. Otherwise, sometimes you will see bugs in your program. Okay. So in C language, the literals are stored in different locations. Because what? C language, you can update it. And Java string are immutable. So basically C language, if you do string 1 5 equals X. So pretty much this guy, I'm sorry, 4. You assign, so pretty much this guy can be changed to X. But not in Java. Java doesn't allow this. And Java don't have this individual adjacent for the characters. Is that okay? You can only use the character add, but that is only a get function. You cannot set a single character. So now let's look at this character 1. So here actually we have these two, string 1 and string 2, right? And then we actually print out this one as well. So the first one we print out, we have an E, but this E actually I don't have changed like new line. I should change that. So the second one we actually compare string 1 and string 2. So they actually are false. And then I do string compare is true. Okay? Is that okay for this one? So this is what you say when you do string compare, they're equal. So string variable, second we are talking about string variable. In C language, there is no real type for string variable. So you can only use fixed size array, undefined size array, or you use a pointer to character. Okay, 3 different ways of assigning it. And on the right side, you can use intern string, or this one, the array of character representation. It said that array of character representation, you put a O in there, okay? Backslash 0 means 0x00, it is a pure 0. Okay.
So for the last one, the string 4, if there was no \0, then it would be still a character.
It's just a array of character, but not a string. So when you do string compare, what will happen? If this one is not, what will happen?
The other one.
So basically, str4 maybe has HELL, right? Oh, right. After that, you will get out of bound, right? So when you compare with somebody like S3, right? It only had a hello. So to compare, actually, this compare over there, here is the backslash 0, and this one doesn't. It will continue to compare, but the two won't be equal. Right. And because it will go out of bound, when will it stop? You will see until it see a 0 somewhere. So you sometimes print out a lot of garbage, not something you intended for. But C don't check boundary. You know, it's different from Java. Java check boundary, so Java will inform you that you are array out of bound or something. In C language, they don't check your boundary. Okay? So now let's move on to the next one. So this chapter need to be after the pointers, so people will know what's going on. So these two, string 1, string 2, unchangeable. Okay, cannot change space string that connected to, but can use pointer that can be changed. What's that? String changing string variable cannot change space string variables connected to. Okay, and then can change. So it is okay or not? It is okay or not? It is okay or not? Assigning it, this is okay, but you cannot put something like A, B type things. You cannot connect to that. Okay, this way is not. It's not array of characters. So this one is only assigning a pointer to it. Okay, number 2, cannot change space string variable connected to, but can use pointer variable that can be changed. So string 3 point to the same space as S1 pointing to. Okay. So actually, if you change the content for S2, string 2, or string 1, I think it's still okay. You can change the content of the address. So string 1 or string 2, you can assign some pointer or data to it, okay? But what happened is like the hello or goodbye will be lost, right? It's stored in global area, but those two strings will be lost. But if you try to assign the value to another one, string 3, then string 3 actually you can make modification to string 3, but it doesn't affect the connection for hello or goodbye. Is that okay? Somewhat confusing. Okay, this slide is somewhat confusing. Is that okay so far for this one? Okay, I think it's not that important either. It's a little bit confusing for this page, but okay, changing variable, change part of the string variable. So 0, you can change with y, and the end you change this. This is fine. Okay, this is fine. Important to retain the delimiter, otherwise you will lost the status for a string. Now the next one is string IO. String IO actually in the previous C language talk, we talk about how to get a line in C language. Eric, how to get a line, the whole line. Like to read in some line, like next line in C language. Still remember that?
The caret thing. So it reads until the
next n. But which function will do that?
Scanf or
no,
get.
You can use scanf, but actually getS is easier.
Yeah.
Okay, so next slide is like this. What is the next? Finding the token. So this one you can use the scan f and then something you used before. You can actually use the format with something like you put data. This one, the whole line, right? Everything but not new line, right?
Yeah.
You can use that, so you can use that one to get a string. So this one actually right here, you can put this, and then here \n for it. Okay, you got it. How about next token? Only a token. This one, this side is scan f a single string, right? You will just read, and then you face mean the \t \n and space. It will just read up to here, right? That's a scan. That's a single token. How about a single character? How about a single character?
Just C, right?
Get CHAR, right?
Yeah.
Next character is get C or get CHAR. Get CHAR and get C are different. One is a row type, one is a cook type. Okay, get CHAR is cook type. Get C is row type. Row type means the data is unprocessed. So that's a different way, different level of getting data. So now let's look at this over here, string input. So scanf is a universal function. So scanf actually can be do to replace next line, can be used to replace next, can be used to replace next integer, can be used to replace next double. Okay, so basically this scanf is a general function that help you to scan something into the C program. Okay, so here actually you can just scan in the token. If you use that, you can scan in the token. Okay, and this one you scan in a token, but with limited number of character read. After that, what will happen? So if you have some sort of input, you type 30 words. What will happen to those not read by this name? Name only requests for 10 symbols. What will happen to those other 20 symbols that not read by this scanf? So if the string is less than 10, you will finish with a \0, right? So shorter than that is base read normally. But if it's actually longer, you will stop at 10. And any more character will be saved for the next scan function. Is that okay? And we don't know what
Yeah.
this function will be. It may be reading in a character, or it may be reading in a double value. We don't know. Okay, so depend on the next one.
Huh?
Hello.
Yeah.
Now next one. So string input continue to read in a line with regular expression. So here it actually is similar to regular expression, but it's somewhat a little bit different. So you have a percentage sign, and then what this one called bracket, and inside there here actually is what a set, similar to regular expression. So regular expression has set, so you can use the set notation. So plus minus and these symbols are allowed only for the number. So number can only be this, and I think this number is more or less like phone number. This number should be +1 510 794 9428, something like that. It's a phone number, and phone number sometimes has plus or minus. So that number is for phone number format. And the next one is \n, not including \n. So everything until you read the next line. But the next line, what will happen to the next line mark? We don't know. Again, it's left off to the next scan function. Is that okay? So this one actually is not a full set of regular expression. It's only the set representation. Is that okay?
Uh-huh.
It's not a full set of regular expression. It's like just part, the set part. Okay. So read it like the set part. So here actually string output, you can print a single string with printf. You can actually put some space, and then with minus sign you will do left adjustment alignment. So basically you have minus sign, this rig will go this way. Without it, you actually is the right adjustment. Okay. Is that okay?
Yeah.
That's the definition for printf, same as Java or any other languages. So the next one actually string IO actually is used to first read in a name. So a name is a token, so I use the S. And I use again use like 10 string to figure if I type longer, what will happen. And then after that, I need to get a character. What is this character for? Why here I need to put a get character? Because if I hit return, that return need to be consumed.
Yeah.
This only take care of 10 of them. So after that, I enter the phone number, same thing. I need to consume the return. And then the address, I need to consume the return, and then put out something. Okay. So let's look at this program. So this one is called string 0. So here I just run the program. Okay, I don't want to compile it. So here first I type in my name, say like this, right? Because what you want me to type the name again, right? But here, what's wrong with this? Why the second one being escaped? Because I only scan a string S, so that's the token. So this one can only use a single token. So when I type in with space, it is not allowed. So let me quit this one.
So you have to use gets, right?
Yeah, gets S will get the whole line. But here, it only requests for a single character, single name. So I can put this, right? So Eric, second one I type again for 10 character. I try to use a longer name. Okay, so what happens is like I put down the name, right? But actually this one actually is too long, and then the number get character only get one. So actually it even doesn't take care of it. Okay, you know what I'm saying? So what happens is like the first one read the error less than 10, that's fine. This one comes down. The second one read for 10, it trump somewhere and get 10. After that, you get a character, so kill another one. And then after that, the number is being read in. Okay, because there is a 1, so it passed, so get a character. So this one actually is a poor design. Okay, this one is a poor design. It's not a good design for not a robust design. I just copy it from somewhere, so let's just try again. So this one is some sort of vulnerable software. You can only follow its own rule to do something. Okay, you can only follow some rule, etc. So try not to, design some software like this. I get this example, so I try to make it useful, but I find out that a lot of them is not really that good. For me, if there's a name, I would rather use what? I would rather just use a get s and get a whole thing in there, and then I find the first space, and then try to just assign the first part for the first name. Okay, that would be better. And after that, each one take care of the return n as possible, /n as possible. Okay. So the next one is we finish this one. The next one is input output example. So this one actually it has a string comma with 10. So basically, when this one I want to key in, I need to type my last name, comma, and then my first name, and then you print out my name. So here the thing is like the keying pattern need to be follow the keying pattern assigned by this scanf, and this type of input is not popular now. People no longer do this. It's too restrictive. So the next one is read the whole line. You can use a get s or get f get s to read the whole line. And then command, you can use printing. Use put s and print s, put s and then f put s to print out the whole line to your monitor. And here are examples for f get and f put. So you open the file. If it cannot be opened, then you will quit. So here is an example for string puts. So we have a file name 81 buffer 101. So basically this one you can assign a file name, and then you open the C file for reading purpose. And then if you cannot open it, then actually you just quit. Otherwise, we print out the file name and then start to read something from the file and then put to the output. Okay, so the result is I copy the I Have a Dream talk by Martin Luther King, Dr. King, and then I read it in and put it out here. Okay, there's an example right there. Array of strings. Since strings are just array of characters, so array of strings actually means array of characters. So it actually is just 2D. I'm sorry, I changed to different color. 2D character arrays. So this means a string is actually 2D character array. So array of strings demonstration array a string underline array project. Sometimes it's useful to have an array of string values. So this is a typical way of writing it. This is a typical way of writing an array of strings. So basically, Again, when you meet something like this, read to the right, okay, read to the right, and then you see an array. So this one is an array. And right here, go back. The previous one month's name is a pointer. What type of pointer? It's a character type of pointer. So it's an array of character type of pointers. Read to the right is an array. So it's an array of certain elements. What type of element? It's a pointer to character. Is that okay? So that's the basic way we read it. But this one actually you can also use character, month's name, and then this, and then 13. Okay, two are of the same effect. And I personally feel this is not bad. Okay, not as confusing. Is that okay?
Uh-huh.
So right here we have a pointer, and this one is seven pointers, seven array of pointers, and then there is the day. That's an array of character of 10 characters, but you save one, so at most it can only store 9 characters, and then you actually try to print a day, so you get a day of 9 character string, and then you try to compare whether it's the same string or not. But the function given here actually is primitive. It's not really the best compare of the string. So if the day less than 7 and this, we increase the day. So until there's a match. Okay, so this actually is not a best example of finding which day it is. It's actually using the while loop to iterate through all of them to check whether it is the same or not. But it can be easily done by just a string compare. But this one, let's look at the program. So the one is actually in chapter 9 is a string of arrays. So right here, let me point out this project. So right here, as I said, this one is not coding wise. I don't think this is a good coding. So there is a array of 7 pointers, and each pointer assigned with some string. Okay, so totally is a 7 strings. And then you enter a day. You try to enter a day, and then the day is a string of 9 characters, and then compare each day, whether it's the same or not. Okay, if not the same, we continue to increase the day until if it's more than if it is less than 7, that means that there is a match from Sunday to Saturday. Then we print out the day and the day's name. Okay, so otherwise you say there's no day, but it's same string. Actually, you can use string compare. So this is a custom design string compare, but even this string compare is not the best design. You compare the length, and then after that, you actually compare 2 strings each element. If not the same, we break. But it doesn't cover the string of different lengths or something. Okay, whether you continue to compare which one's bigger or smaller. So basically, it just return yes or no, 1 or 0, true or false. It doesn't return the difference of the characters. So that actually is not the best design. But anyway, let's run it. So enter a day for the day. So if I type in lowercase, okay, so it's no day. Okay, so now I run again, and then I say Friday. You have to be exactly follow its dual, then you would get this. Okay, so that's one program just to demonstrate the array of strings, but it's actually not the best design we can have. So again, that's array of strings. So we get that down. And then next one, starting from here, we have string of 1, string function 2, and then string function 3. So basically here we are talking about the string functions, each of the individual string functions. And these string functions, I believe you probably have already used some of them, or even most of them. So let's just get started and see example one by one. And remember, these functions are actually covered by your 45 class project, string classes. Remember that? All of the function actually is covered by that, because you have one C array and use for the string class. Remember that one? Hello? Hi, Eric. Remember that one?
Which one?
You have a project actually on the string class, but the string class is implemented by an array of C string. Remember that one? And there is one you need to use all the string function. So actually, this part is very important for you to review. Okay.
Okay.
Even though it's very simple, but it's actually very important for you to review. So first one, who has strlen. So what is the number will be reported here? It's a string length, right? But does it include \0 or not?
I want to say no.
Yeah, no. So actually, the real length should be this one plus one. So it should be this one plus one. So say if you have a string called ABC, right? Then the string length return will be 3. And then when you want to copy for this one to another, you need to say character S2 equals what? S2 or 4, I'm sorry. You need to do that. Otherwise, you cannot copy the S1 to S2. So that's a string length. Remember, you need to return one more. Or you have a string pointer S equals memory of K. And then you need to do 4 times size of a character. Is that okay?
Mm-hmm.
So remember, this one actually need to plus 1 for the two copies. So next one's copy from destination to source. Okay, so from source to destination. So this one is tricky. Usually in our habit, in our habit, we actually copy from left one to right one. But this one actually is copying from right to left. And all of the CO library, usually the source on the right, destination on the left. Okay, and then string compare 1 and 2. You will compare string 1 and string 2. Okay, and to call this function, you need to call string.h. Okay, so these are the 3 functions we talk about right here. And then syntax, string length, you put a character array name that can be a character string and return the integer length and not including 0. Okay, so hello should return 5, but physical memory takes 6 characters. String copy from source to destination. String copy before the n characters, before the n characters. So actually it's totally copy n characters. So it started from index 0 to index n minus 1, and then n actually not included. Okay, totally n character will be copied. That's a string copy with n number, n copy. String n copy, okay? You remember the name is called string n copy. You copy the first n numbers, n characters, and then the next one is string comparison. So compared to string, the value based on the first character, they differ. If less than 0, actually, if the ASCII code of the character they differed, the smaller one for S1, then it will be less than 0. Greater than 0 if the character is bigger for in ASCII code, and lowercase is bigger. Okay, 0 and 2 not differ. If not, we continue to compare the second one, third one. Okay, and until if to the end, if 2 are all the same of the same length, and then if 1 is actually longer after the same one of the string finish, the longer one actually is bigger. Okay, So actually, this one return 0, this one return greater because y is greater, this one return less than because this one h is bigger, this one return less than 0 because this one's bigger. What's this? This one too, some drift and some diff and some diff, and this one is bigger, so less than 0. Okay. So if two are of different lengths, and then the previous few one are the same, it actually compare who is longer. So string comparison compare n up to the n characters. So some actually this one in this case you return 0. It actually the same. Okay. Now let's look at the program for string compare. So string compare, we have a file name and then previous line buffer or something. Okay, we open a file. So when you in C language, you actually define this one called file. Okay, file input string. And here you need to include a standard io.h and standard library.h. But sometimes you see me, I actually may do this. I may include this /file.h. Okay, sometimes some file function they are more file function, but if you just define a file string, that's fine. Remember here you need to put the star, and after that you need to do fopen. So basically you can put fopen here, but usually this is better. Fopen, if it not equal null, then we go ahead. Otherwise it will be the program will break. Okay, so here you check in the file name and then check if the open is successful or not. Okay, if yes, it will return with a file index number, so the number will be assigned to here, right? But here is an assignment, right? And then it take a parenthesis. Then who is compared to this null? Who is being compared to this null? So we have A equals B, right? And this one compared to C, right? So,
Yeah.
so who is compared to
A? A is compared to C.
A is what compared to C?
Is value?
Value? Actually, is actually B's value assigned to A.
Yeah, but like it's
so
B.
if that value is alpha, actually the alpha compared to C.
Yeah.
So this actually is like a function. It's like a equal function, but it actually will return alpha. Is that okay? So this has a side product of assignment has a side product of return value. If you look at it in C language, okay, in C language, I believe in Java as well. In Java, so some Java assignment also has that effect. So this one actually, when you do this, so this one actually is better than writing the open over here because you don't check the result for open. So this one it is not null. If it is null, then we break. If it's not null, we go into here. So each time we get from buffer of this size and how many character from the input string. So it's like from the input string. So it's like from input string file, we keep say if buffer is a box of 250 characters, so we fill it in for that one, okay? And then after that, we do buffer comparison with previous line. And
what's the buffer for?
Buffer is something that you read data in. So actually, it's just like a string you put it in. So this one is gets S, right? So you will check if there's a \n, it will stop. It will copy something into this buffer. A buffer actually is of bigger size, usually assigned like 256 or something, more than what a line would need. So it's a buffer. Actually, right here is a 101. Okay, this one is 101. So actually, it's assigned some sort of, so you can accommodate 100 letters. So each time you actually from your file you get some line. If it has a line, if it's more than a line, more than if that line is more than 100 character, you stop at 100 character, and then this one is 100, right? And then you will read in that one, and then compare with this, compare with the previous line. Okay, and then if not equal 0, we print that out. That means that if there is still something in the buffer, if buffer actually is the same, I'm sorry, if buffer is the same with previous line, we don't print. If buffer is different from I'm sorry, if buffer is compare, if it is 0, 0 means they are the same. Okay. If not the same, we print this. Okay, then we say, let me see. If not, if the same, you get 0. If exclamation mark, if the same, we turn the value to be 1. Then that means that we duplicate. So buffer is the same with the previous line, then we print it. Okay, so at the end, the buffer copy to previous line. So it's something that is we read in the line, and then there is a buffer, there is a previous line, we compare. Okay, and then we copy that to buffer, and then next time I load another line, compare to it, see if the same. If the same, we say duplicate. Otherwise, we continue to read in and then compare. After that, we assign to it. So actually, it's a buffer to check whether the previous line is the same as the current one. If there is the same, then we say it's duplication. Is that okay?
Yeah.
So this f gets, you can put a string over there, right, from the file, and then a certain size, okay. And f get probably you also have a buffer and then something from the file, okay, and the size. And comparison, actually, you have compare n and compare this. So if the two are not the same, actually we compare the first 10 characters to see the two have the same head or not. Okay, so this one is wrong. So here I'll try this one, string.txt. And actually there are two duplicate line of the space. Okay, anyway, so that's not important. Now let's go back. So that's the first few function we look at. That's the first few function we look at, compare. Okay, second group of function we compare. Okay, so this one actually not a lot. Okay, second group of function we compare. I'm sorry, we look at it will be string concatenation. So again, your source arrays here, destination here. So basically, destination string is over here, and then your source will be appended to it. Okay, so this one's tail will be the tail, or copied by concatenate. Okay.
So it'd be like DSTS plus ADDS.
So if you have str, cat, and then ABC, and then CDE,
so the
it will
output
become ABC, CDE. It will become something like this.
Okay.
So from here, append to here. So it's append. Append the second one to the first one. Is that okay? And the append ends is only n character append. Okay. So let's look at a concatenation. This few program actually not really super. I just want you to actually know about a feature of these different functions. And actually, there are better way of writing the call. I get a call from somewhere, and then it turned out to be so call. Okay. So here again, I have a HS file. So let me open the HS file. The HS file, actually, I'm using the example we used before. I'm using this student. Okay. So only difference is that I add some star in there. So what happened is, like, I open the file for reading. Okay. Again, I check the file handler whether it's empty or not. If empty, that means the open file is failed. It has failed. So after that, actually same thing, I read in the data from the buffer, and then if buffer is not equal star, that means that these are not equal star, right? Then what? Then actually I print out the current edges. I'm sorry, if it is star, actually it's the end of the edges. Then I print out the current edges. Otherwise, I mean, if it is star, I actually print out it and then clean up the current edges. So the edges buffer, this one is actually a buffer. Clean up the buffer, edges buffer, and then I clean up. So if it is not a star, then what will I do? Actually, if it is the first one, say this is Adam Smith, then I will add a comma to it. I'll add a comma after Adam Smith. After that, I actually will concatenate uh, these current edges with buffer. So I added a buffer into current edges, but it's the buffer size minus one. What does that mean? The backslash 0 is not in. So that actually copy the second line to here, but in between there is a comma. After that, I continue to do this and put a comma in between. Okay, until I see a star, then I just print out the whole string. So that's wrong, this one. So let's do student. Okay, so as you can see right here, the first one I actually have Adam Smith and comma, and then what? The first one actually I'll do that, right? First equals 0. I actually don't put a comma in there. Second one, actually I will put a comma first and then add to it. So what happens is that the first time I would actually copy this Adam Smith to here. And then because first original is 1, so now I set it to 0. Okay, the next one I read in another line. After I read in, actually I put a comma after this, and then I put 1H3 behind it. Okay, the next time I actually read in CA9007, so I put a comma and CA9007. And the next one I meet a star, so that's it. I put now this whole thing. Okay, so this one actually is what usual use for actually print out a string and adding some print out edges, and in between the lines of the edges we put comma. So here actually, for example, if we have A, B, C, and we would like to convert it to A, comma, B, comma, C. There are two ways to do it. The first way to do it is like the first one, I make an A, and then the next one come up, I put a comma, and then I put this in as well. And then after that, I put another comma and then put it. So this totally actually is the first one don't have comma, the rest of them has a comma. Okay, that's one way to deal with. The second way to deal with is actually A comma, that's a group. B comma, that's a group. And the last one, C, will be left alone and put it there. But this one actually is not as good, because this one you need to know the total length we have beforehand, because I need to know that, okay, we only have 3. So if the number of the symbol or lines are 3, then the first 2 I will add comma, and then the last one I don't add. But this one you don't need to know about. The red one you don't need to know about the total length of the array of strings, because the first one I just put it in. After that, each one of them I just put comma and the data over there. It will be fine. Are these okay? Hello?
Yeah.
Is it okay? So there are two ways to deal with it, but I think the red one is better. And this one is using the red one to concatenate the 3 lines together and put comma in between lines. Okay, so the first line, we don't do it. Second line, I put a comma there and then put the second line data into there. Okay, Keep doing that until you meet a star, then we stop. Okay, that's the way this is done. So that's it. That's for the concatenation part. And to search a string, be careful right here. You can search a character or search a substring. You have two ways to search. You can do search for you can search for a character or search for a string. So string character or string string. String means to search a string from the original string. So it will return what? The first occurrence. So it will return the first occurrence. So if, for example, you have A, B, C, C, D, E, C, D, F. Okay, and now you try to search for C, D. That occurrence will be returned. But remember, it returned the character pointer. It's not returning the index. So here, it doesn't return 3. 0, 1, 2, 3. No, it doesn't return 3. Instead, it returned the pointer for this one. Okay, it's different from Java. So Java's substring. I mean Java's the index of it returns 3. So actually, I can do substring or something in this. But this one actually, it return here, return the edges starting for this. So you can use that pointer to print out this as a string. Okay, that's possible. So be careful. This one return the pointer for that location, not the integer. So same thing for this search CHR, search RCHR. So search RCHR actually is what? To search from the end of the string to backward. So actually this one is a reverse character search. Okay, RCHR is actually reverse character search. Is that okay? Hello, Eric. Is that okay?
Yeah.
So this one actually we open the file, right? And then we get something from buffer. We search for the later percentage sign. Okay. When you find that, we get location. So this location actually is what? This location actually is a pointer. So if we have this A, B, C, percentage C, D, E, actually we report this pointer over here. Okay, and then actually what do we do? We copy from the source to destination with this much byte. So this one, buffer's location is here. Buffer location is here. Buffer is a pointer. And here you report location. So location minus buffer is operations for address. So actually you return, this one is the length between here. Is that okay? That's the length between here. But normally the index of is like index of the leading location is 0, so 0, 1, 2, 3, right? And then this one buffer, for example, this buffer address is like 500, right? So this one actually is 500, 501, 502, and 503. And then 503 minus 500 is equals 3 minus 0. So it has no difference. Is that okay? The size is still be this, but using index of you have this, but here you use pointers. Okay, and the location of these, you copy these 3 into something called nocam, right? After that, you put a 0 at the end of nocam, so it becomes this string, and then we print that out. Okay. So let's look at this. So let's look at it. There is a test.txt. Okay, let's look at this. And right here, I also open the test. Okay, so the test is like this. So what happens is that for these 3 lines, as I described, the result should get this up to this, not including percentage, this and KKK. Okay, that's what we expect to have. So the main program is right here. Okay, I just run. So this one is called what? The file name is called test. Okay, So we got it. Now the last lecture, function 3. Function 3, I remember, had 2 programs anyway. So the first one is to parse. To parse, actually, this one has the str token. It's somewhat like str token. So it's actually trying to break down the string using a set of tokens. So it's just like split. Okay, so call string token actually you will actually separate by this. So actually cut here, and maybe cut here. So it's a short string will be done. So first call, the first time you call it, you will get a pointer to this. Second call, you will get this. Third call, you will get this. Okay, and each time you actually you actually will get some split. Okay, so actually the delimiter is a string consist of the delimiter characters. If we call string talk, and then the string argument for the first argument, it finds the first string separated by the delimiter in the string. If we call stop with null, the first argument it finds next string separated by the delimiter in the string. It currently processes it. So basically, there's a string, and then we use a delimiter, and then we will find the first string separated by the delimiter. So what it actually means is like if I have a string, this is str, and there's a percentage like this. The first one, when you call, you actually get this. Okay, and then if we call stop with null as its first argument, it find that if the first argument you find is null, then finding the next separated by delimiter in the string, it is current processing. So stop make alternation to our string. So our string will be changed. Okay, first make copy of it before you. So actually this one is destructive operation. So what happens that after that it jump it, and then you need to do it afterwards. So it actually is a destructive operation of split. Is that okay? Is it different from? It's different from what? It's different from the split, even though it's similar, but it's different from string. Different from split. So this one calls string parsing. So next one, actually, let's look at the next one. Parsing. So this one, actually, we have this different thing. So we open the file again, and then get buffer for a line, and then we increase the line number. And then token, we actually chop the token. Okay, so we get a token until that the token equals null. That there's no longer data in the buffer. So token actually you chop, you get one data, and then if you had not finished, it's still something in there. You keep doing that one by one until it actually is null. Other than that, you have the token number. Each time if the token number less than number of token, you compare a token with the data in the tokens. So basically, it's checking whether the token have been put into the tokens or not, and then you increase the token number. So basically, the tokens is a table. This tokens is a table, and there is something called token number. So it's somewhat like a stack. Okay, so here if you try to actually you try to see some sort of in buffer, you see a separator. So you get this that's token, and then you compare that token with the whole table, see whether there is something. If the table there's something it met, then actually we actually if something we met, then we would increase the occurrence. increase the occurrence by the put a line number. So actually we actually copy the token to a certain location. If number of tokens, if actually we cannot find it, and then we add a new item into the token table. So if you find it, and then the number of tokens will not be the same with the T num. So T num actually you search through it. If there's a compare to be 0, you will stop. That means what? That means you have hit somewhere. The T number will stop here and then you don't do this. If not, you keep going for the 2 T num until you hit the number of token. That means it's not in the table. If it is not in the table, we allocate the token size and then copy the token to the token number. So we actually copy it here. Okay, something like that. So actually, it's finding all the token in the table. I mean in the string or file. So that's wrong. Okay, this time we use a file called simple. Okay, but this function actually I don't think it's too easy to use. So basically, let's open the simple file. The simple file actually only has these A, B, C, D things. So actually, you will find A appear on line what number is. Okay. So that's the result we get. So basically, each time you search through your token table, and if you actually cannot see it in the table, you allocate a new table entry for the new token and put that token in there, and then increase the token line number. There's another array called token line number. You actually put the line number there. That's the first occurrence of that token on certain line. Is that okay? Is that okay so far? So this one is string stroke actually is not a very efficient function for split. So actually you can actually find some split function in the internet. Okay, I believe that there's something some people has already do it. The next one is actually a very important function called print to string or read from string. I think it's the most important one so far. So print to string. Print to string is what? Sprint function. And sprint function, I told you, this function is similar to Java's string.format. And string.format is similar to system.out.print f. Okay, .out.printf actually is print to console. String.format with some format and some parameter actually converts things to string. So this sprintf is similar to this string.format. It actually provides a formatted output string. So you have the name, put it here, last name, first name, put it here, and that result print to a buffer. But if you don't have S, you will print the whole thing to a screen. So this without S is actually equivalent to system.out.printf. With S is actually equal to this string.format. Is that okay? Eric, yeah. Is that okay? And what is the use for this sprintf function? If you think of a good application for this sprintf function, what is a good use for this one? You print something to a string.
I don't know. User input?
No,
I don't know.
It is used for the toString function. So let me write a simple toString function. Okay. So let's close this project. Let me write a simple toString function. So this time is a console C program, okay? So let's go to chapter 9. So here, let me put it in the demo part. Create a new project called chapter 9. Okay. So in chapter 9, I actually create something called format. Okay. So right here, let me put this project over there. Okay. And this one, it actually this sprintf. Actually, you need to include the string.h. So here I need to include the string.h. Okay, now the first thing I'll do is like I need to define something called structure. You know, because you have no class, so let's use structure point. Okay. So here I have integer x, integer y, right? And this actually define a type, right? But in here I will define a object, a structure name. So I should do type define struct point as a point. So define a new type called point. Now I can have a point P1, P2. Okay. I declare a point on P1, P2. So here I would say P1.x equals 1, P1.y equals 2, right? P2.x equals 10, P2.y equals 20. Okay, so I set up 2 points. Are you okay so far? So far with this 2 point structure? Okay, the next one I'm going to do something called format. So here I will do format function. Okay, format function is like here I will accept some sort of let me see. I'm sorry. Let me see. No. Let me see. Okay, let me see. Here I should return character, pointer type. Okay, and then say format. Okay, and then I would need to have 1 point P, and then here I would say my format. So here should be character, and then for that format actually should be a array. I mean, let me put it as a pointer. Okay, as a pointer, right over here. So I actually do character star buffer equals here would be let me see. Here let me do memory allocate, and then here 556 times size of, and send it to character. So here I declare an array of 250 character as buffer, right? So here I do format with that. So I say sprint f, print f to string buffer. So I print something to buffer, right? And then what I'll do is here I'll do point that, right, comma, right, $d, okay, comma, and then p is actually is a structure, so it can be has the aggregate operation. So I can put p.1, p.x, p.y, and then I convert it to buffer. So now I return buffer. Okay, so that actually I will print out a data in between. Replace this first parameter with p of x, p of y, replace this, and print the whole thing to buffer and then return buffer. So this one will generate a string. So this function effectively is equal to string function for the structure in C language, for the structure P in C language. So now let's see what happened here. So because that's that, then what I'll do right here, it will be printf $sign, I'm sorry, percentage sign s less n for what? For format. I put in P1. Okay, that will print now P1. It's similar to P1's to string function. And then I copy again and then try to format. So if you don't like my word format, you can convert it to string in C language. That actually is fine. Oh, something wrong. Oh, I missed A over there. Okay, that's fine. Tiny mistake. Okay, what's wrong? Incompatible argument type for format. Incompatible argument type for format. Arguments be, oh, okay, here I missed something. So here I need to give it a format. Do I provide a format? No. Actually, this one I don't need a format. So let me just delete the format away. Actually, I can put a format and put it here. Ah, let's keep it. Okay, let's keep it. Let's keep it. Okay, let's keep it. Let me see. No, I don't want to keep it. This one's fine. ToString is fine. So let's do this. And then print. Okay. So actually print out 2 points. Is that okay?
Yeah.
Is that okay so far?
Yeah.
So actually it's a ToString function. That's why I tell you this one is very important. Okay. So this is one format I will do. So this one, let's assume that this one, let's change this name to say ToString. Okay, this one, let's say this is ToString. So I convert actually convert the function for 2 point to string, and I can copy this one and move down. And actually here I change it to format. And in format here, I want to have a character and then $sign format. Okay, so here actually I will copy these two as well. Okay, and then put it down. Okay, and here actually I will do right here. I'll do, instead of using string, ToString, I'll do format. Here I'll do format. Okay, and then here I can copy this whole thing. Just cut. Here I paste and comma. Okay, and this thing I just copy again. Put here, and I paste. Okay, so this one actually is a formatted output for this, right? And then this one here, I put the format over here for the format. Okay, so here, if I don't like this notation, I put a dash in there, right? I can specify that using the format function. What's that? In format, undefined reference to format. I'm sorry. Oh, I have a typo. Okay, format. So that's wrong again. Compile again. So this one, let me close this one. Okay, for the main function, I compile. and wrong again. See the difference now? So the toString actually is designed purely for point, right? And then format can also be for point, but actually format you can assign different format for it. So actually you can also delete this if you don't like it, you know?
Oh.
So actually it gives you more freedom. Even though the two functions are similar, you don't need to hide that thing in the function. Then it will be built in. You know what I'm saying? So one is called toString, one is called format. But these two functions are written in C format. Is that okay? So that's why I told you this sprint is super important. Super important. When you do that, you need to include a string.h. You know, okay? Because otherwise, in C function, you would say it's not object oriented, right? Then how can I do something for a structure or something as toString function, right? That's difficult. So these two as a good example for you. Is that okay? Hello, is that okay?
Yeah.
And then we move on to the last topic. So we finish this one, parsing, and then we finish format, okay? And read from string is the opposite operation from sprint, but this usually not as important. You know, usually you read from file or you read from console. But if you want to read from string, it's okay. You just put buffer in there. You actually read from the buffer. Okay, that's it for this chapter, chapter 9, string. And thank you. And we will move on to the link structure. Okay, thank you. Bye now.